Hello, CS111 students. This is my video for problem set 3, task 1 on simulating trees. Um, just as a reminder, these videos are optional. I'm just going to read through the problem set description and you can go read it yourself instead of watching this video if you prefer. So the first thing to note is that on this problem set you have a choice. This task 1, is based on turtle drawing. And task 2 is based on making music instead using the synth.py module. So synth, turtle, music, drawing, it's your choice. You only have to do one of those two tasks. The other two tasks in the problem set are required, tasks 3 and 4. So 1 or 2 plus 3 and 4. Which is appropriate because we're doing Booleans and conditionals this week, but this task does not require the use of Booleans or conditionals at all. It's a sort of retrospective task trying to make sure you have a solid foundation of understanding for functions, especially custom functions, parameters, and return values. And this task is a little bit more directed and specific than some of the tasks last week in terms of what you have to do. So, we have pictures of trees. That's what you're going to be doing in this task, is building together some functions that will allow us to draw a picture of a tree. And in addition to drawing a tree, your code is going to be calculating the volume of the woody parts of that tree. So forget about the leaves, just the woody parts. How much volume of wood is there? You could use that to figure out how much the tree might weigh, or how much energy you could get from burning it as firewood, or lots of different things. So we're going to do a little bit of sort of simulation. And we'll be using some parameters to control the tree size in terms of length, and then trying to figure out, well, if that's the length, then how would the branches and twigs grow? And if the branches and twigs are growing like that, how big would it be? So we're going to be both drawing the trees and computing their volumes. So in this first picture of a tree up here, you can see that it is growing upwards like trees normally do, and that's because we have called a testing function. But in this second picture, if you just call the tree function itself, which we'll talk about in a minute, it'll be on its side because the turtle normally starts pointing east, and the tree is just drawn in whatever orientation the turtle is pointing in. It's not always drawn pointing straight up. So there are several subtasks, and you should do them in order. You're responsible for writing some documentation strings for every function that you write along the way. We have a schematic here that is a good reference point for all of the different parts of the tree, how big they should be, what angles you should use. You don't have to absorb all this information right at the start, but it's a good place to refer back to when you're working on the different tasks, as you are trying to figure out, okay, now I'm doing this part of the tree, what should I do here, right? Usually this schematic will have the answer. And let me just walk through it really quick. So all of the lengths in this example are computed values that are variable depending on the parameters to the tree function. This tree in the schematic was called with sienna as the color and 225 as the trunk length. And as the schematic shows you, the trunk length is literally just 225 units long. The branch length is determined from the trunk length by a formula that we'll talk about in a second. In this case, it would be 135. Similarly, the length of each of the twigs is determined based on the branch length. In this case, it's 81 in terms of length. And the leaf length is also determined by the twig length, so that's 40.5 in this example. As far as the angles go, there are 4 branches, and there's 40 degrees between each branch, so totally they span 120 degrees. And they're evenly distributed around the angle that the trunk is at. So in this case, the trunk is pointing straight up, so the leftmost branch is 60 degrees left, the rightmost is 60 degrees right. For the twigs, relative to the branches, they are 30 degrees left, 30 degrees right, and straight up the center. So 60 degrees between the outer 2 twigs. And finally, for the leaves as well, there's 60 degrees between the 2 leaves. They are 30 degrees right, 30 degrees left from the angle of the twig that they're attached to. So you can see there's sort of a pattern here. For diameters, in this particular tree, we have a diameter of 15 for the trunk, 7.5 for the branches, and a non-simple number, 4.3301, with some other decimal digits for the twigs. But you should use the provided function called split diameter to compute those diameters. So, the text down here below the image has all of the same information I just gave you, plus some of the formulas for things. So, in terms of color, we color everything with whatever the argument was given to us is as the color, except the leaves, which have their own color that's predefined. For the lengths of things, the second argument to the tree function determines the length of the trunk. So the tree function takes two arguments, color, length. The second argument is just directly the length of the trunk. The length of each branch is 3/5 of the length of the trunk. And then, by the same formula, the length of each twig is 3/5 of the length of the branch that it's attached to. So, trunk, branch, twig, the branch is 3/5 of the trunk, the twig is 3/5 of the branch. And then the angles I already described, they're not variable, they're always just the same angles for every part. I should also mention for the length, the leaf length is half the length of the twig it's attached to. So the ratios are 3/5, 3/5, and then 1/2 as you go down to the different parts of the tree. For the pen sizes, so we've provided a split diameter function. What it does is it computes the diameter of outgoing pipes at a split for a certain number of outgoing pipes, such that the sum of their diameters is this, or sum of their cross-sectional areas is the same as an incoming pipe. So you give split diameter two arguments, a diameter value and a number of splits to split it into, right? And it's saying, well, if there's water flowing through a pipe and we want to split it into, let's say, 4 smaller pipes, how big do each of those pipes have to be so that the same amount of water flowing through the big pipe can still keep flowing through all those pipes? So just call the split diameter function with the appropriate arguments. For the branches, since there are 4 branches, we're taking the trunk diameter, splitting it into 4. For the twigs, since there are 3 twigs, we're taking the branch diameter, splitting it into 3. So that's how the tree is laid out. Let me talk about the subtasks. So the twig function is the first one, and it has 3 parameters: bark color, diameter, and length. Bark color determines the color of the woody part of the twig. Diameter determines how thick it is. You can use that diameter straight as the pen size in Turtle Graphics. And then length determines how long it is. And its job is to draw a line with the given width and length and color. And then draw 2 leaves, which are 30 degrees right and 30 degrees left from the orientation of the twig itself. And then it has to return the turtle back to the starting position when it is done. And that's something that all the functions that you will have to do is return the turtle back to where they started when they are done. We've provided in the online description a picture of twig with arguments Sienna, 10, and 100. And if you call the test twig function, you should see exactly the same picture pop up. The only difference might be we don't care whether you do the left leaf or the right leaf first. And so the leaves might overlap in different ways, and that's totally fine. Okay. One thing I will note about that picture is that you will see the turtle in black. That's because the show twig function that we have for testing your twig function does that. And that position that you're seeing is both where the turtle started before the twig was drawn and where the turtle has to end up afterwards. Okay. Now, the twig function draws is something relatively simple. I should also mention, by the way, that those leaves are drawn by a built or a provided leaf function that's in the starter file. You just call that function. Tell it how long you want the leaf to be. You have to calculate that value. Other than that, it does the coloring and the movement and everything for you. So besides drawing stuff, your twig function has to be fruitful. It has to return the total volume of the woody part of the twig, excluding the leaves, which is just basically a cylinder, right? You know the diameter, you know the length, so if there were a cylinder that had those sizes, what would be the volume? And we've provided a function called cylinder volume that you give it a diameter, you give it a length, it'll give you back the volume number. So for twig, all you have to do is call that function with the right numbers and take that value and return it as your return value from the twig function. We've provided a text summary of exactly what should be printed when you call your twig function using showTwig. And you could even use the diffchecker website that we have linked in previous problem sets to check that text against the text that you get when you run it to make sure that all those numbers are perfectly accurate, because it's a pain to try to inspect it by hand. And it gets even worse with the other functions. So let me move on to branch. The branch function is going to draw a line and then 3 twigs, right? So if a twig has 2 leaves, a branch has 3 branches, or has 3 twigs, and therefore a total of 6 leaves attached to it. And what we're doing here is we're building up these functions to be more and more complex using smaller functions as the basis. So the branch has to draw a line and 3 twigs, and it needs to return the total volume of everything that it drew, including the 3 twigs plus the volume of the branch itself. It takes 3 arguments: bark, color, diameter, and length, just the same 3 arguments that twig did. And like twig, the first thing it's going to do is take that diameter and length and draw a line that's that thick and that long using the bark color as the color. When branch is calling the twig function, which it must do to draw the twigs, as we said before, the twig lengths are 3/5 of the branch length. So it's going to use that as an argument to specify how the twig should be drawn. And like we said before, for the diameters, use the split diameter function with a num splits of 3 to determine the diameter of the twigs given the diameter of the branch. The twigs are drawn 30 degrees left at the center and 30 degrees right compared to the angle of the branch itself, as we already covered. And you must use the twig function to draw the twigs. You can't use other drawing commands to draw them. That would be a waste of your time in programming, but also a demonstration that you're not really understanding the way that functions can be used together to achieve more complicated results. You will have to capture the results of those twig function calls in branch so that you can add up their volumes to find the total volume of the branch. You do not need to and should not try to find the mathematical formula for the volume of the branch plus twigs, even though there is one, because it'll be rather complicated, and it's much simpler to just say, well, the twigs know how big they are. Let me take their results and add those into the result of my the branch part that I drew, and then that total will be the value I return. As always, the branch must put the turtle back where it started when it is done. And we've given you a demonstration, a picture of what branch looks like with certain parameters. We've given you a testing function in the provided starter code that draws exactly this branch. Again, maybe the leaves will overlap differently for you. And again, we've given you example output and a link to that difference checker website if you want to use it to carefully check that example output. So that is the branch function. Now that you've done twigs, and then twigs enabled us to do branches, branches will enable us to do the tree. So the tree function takes just 2 parameters, a bark color and a length. And like branch and twig, it has to return the total volume of all the woody parts that it draws, so the trunk itself, plus the total volume of each of the 4 branches that it draws. And just like in branch, we're going to call those functions, get their return values, add them up, and then add a little part for the trunk, and that'll be our result. Like those functions, tree has to put the turtle back where it started when it is done. And unlike those functions, it doesn't take a diameter parameter. It just has 2 parameters. For the tree, we compute the diameter of the trunk as the square root of the trunk length. So just take your trunk length, take the square root, and that'll be your diameter for the trunk, which then will determine the diameters of the branches, which will then determine the diameter of the twigs, and so on. And just like the branch function, when we're passing lengths to our branches for the tree, we're going to use a ratio of 3/5 for the ratio between the length of the trunk and the length of each branch. As I mentioned before, the branches are evenly spaced across a 120-degree arc that's centered in the direction the trunk is facing. So there's a 40-degree angle between each branch. We have provided you, unsurprisingly, with a picture and a show tree function that should produce exactly that picture again, maybe with some minor differences in the overlap of the leaves. We have also provided you with the show tree output. There's a little place that you can click to show the output because it is rather long. So we've hidden it by default. You can click again to just compress that back up. And those are the functions that you have to write. So for testing purposes, we have a show twig, show branch, show tree. Those functions are good for testing. We've already provided function calls to those functions in the starter code. You just have to comment or uncomment them when you're testing a particular function. When you're done with the tree function, we've also provided a show growth function that shows trees of different sizes, 3 trees in total. And it should look like the very first picture at the start of the task. The last 4 lines of output, beyond all of the output that it does talking about what it drew, should be what is shown in the website description, which is the volumes of the 3 trees that it drew. One note when you're testing things is that your tree should look correct even if the turtle doesn't start at 0, 0 or starts facing a different direction. It should always draw in the direction that the turtle is facing and based on the position that the turtle starts in. And that's basically what you have to work on for this problem set. If things are working correctly, right, then your code not only draws trees, it can also tell you the volume of those trees. And, you know, our model of how trees grow is maybe not physically accurate to how trees grow in the real world. It's a little bit simplified to keep the programming concept simple. But this simulation, right, it draws the tree to show you what it looks like, and it can tell you how much wood is in that tree. And you can call it with different numbers to sort of try to get a sense of the relationship between the length and the total volume, right? We have some rules that are sort of approximating some sort of physical constraints about the diameters and the lengths. And we could use this program to basically tell us, like, okay, well, if those are really the rules about how trees grow in the real world, then, you know, how heavy would they be at a certain size, for example? Later in the class, when we talk about recursion right at the very end, we will have the tools to do a slightly more accurate simulation, although it's not quite decided yet whether that will be assigned as a problem set or not. One last note here is that our testing code rounds values to 3 decimal places, just to make things easier to read. But your code should not do any rounding of any kind. So that's it for me on this task. I will have other problem set videos for the other tasks in this problem set.